In this video, we're going to look at some application problems for logarithms, and we're going to start by looking at what's called common logarithms. Common logarithms are logs with base 10. If the base is not written in a log, it's assumed to be 10. So you'll see on your calculator that there's a log button. Some of the newer TI calculators, with the log button, you can input the base. But on most calculators, the log button does not allow you to input the base. So if the log button does not allow you to input the base, then that means it's doing common logs or logs with base 10 only. So we're going to look at an example here, and a lot of times in word problems when you have like a formula that's modeling something, they're going to use logs with base 10 or common logs. So you won't see a base like in this example. So this is example 8. It says the percentage of adult height attained by a boy who is x years old can be modeled by f of x equals 29 plus 48.8 times log of x plus 1. Where x represents the boy's age and f of x represents the percentage of his adult height. Approximately what percentage of his adult height has a boy attained at age 8? So this is really just a plugging in problem. So we want to know what percentage of adult height the boy has at age 8. X is age, so we're going to plug in 8 for x. So we're going to calculate f of 8, which is going to be 29 plus 48.8 times log of 8 plus 1. Now, one thing with doing logs on the calculator is that you have to be careful about the parentheses. So I'm going to show how to type this in on the Desmos calculator here. On this calculator, there's no log button on the main screen. When I click over here on the function button, I see the log button pop up. So I'm going to type in 29 plus 48.8 and then times, or I don't need to hit the times, it'll automatically do times, log. And then you see it opens up a pair of parentheses there. Now I can type 8 plus 1 into the parentheses, or I can do 8 plus 1 in my head, and I know that it's just not. And then I'm going to close the parentheses after that. So type that in, and I get 75.567. There's a lot of numbers after the decimal point there. So approximately 75.567%. This problem, it actually doesn't tell me how to round. When you see this on the homework, it's going to tell you to round to the nearest tenth. So that's what I'm going to do here. In the book, they round to the nearest whole number. Just Remember to look for that on my math lab, that instruction for how to round. So if I round to the nearest tenth, it would round to 75.6%. So next you should look at checkpoint problem number 8. It's using the same function, but just finding the percentage at age 10. So do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to talk about natural logarithms. Natural logarithms are logs with base e. So if we have log base e of some number, I can also write that like this, ln. And I usually use the cursive L, but you can also write more of a print L. So ln of x is log base e of x. The ln stands for natural log. I think in some other language, because that's why the L comes before the N and it's not NL. So going back to some of these that we wrote all the way back here, if I have log base e of 9 equals y, and you saw this if you look at the notes, the other way that I can write this is ln of 9 equals y. So we're going to look at example 11. And this is an example of a function that's written with the natural log. We have the function f of x equals 13.4 times ln of x minus 11.6. Models the temperature increase f of x in degrees Fahrenheit after x minutes. Use the function to find the temperature increase to the nearest degree after 50 minutes. So x is minutes, so all I'm going to do here is plug 50 in for x. So I'm going to calculate f of 50, which is going to be 13.4. Now, you have to be careful here because on a calculator, after the ln, it's going to automatically open up a parentheses. You're going to type in the 50, because 50 is x, and then you need to close the parentheses after the 50. If you don't do that, it's going to do 50 minus 11.6 and then take the natural log of that number, which is not what you want to do. So closing parentheses here is really important in getting the right answer. So I'm going to type this into my calculator. So we have 13.4. The ln button on this calculator, there actually is an ln button on the main screen, and it also appears on the function menu. So ln 50, and then close the parentheses, and then minus 11.6. So the answer that I get here is 40.8211. And looking in the problem, it says to find the temperature increase to the nearest degree, which means round to the nearest whole number. So that would round up. 41.8 would round up to 41 degrees. So next you should do checkpoint problem number 11. Do this in your notes, check your answer, and then move on to the homework for this section.